person has a congenital absence of the endocrine pancreas, or the islets of Langerhans, which of the following diseases could be expected in this individual? So let's review the endocrine pancreas and the islets of Langerhans and what this is referring to. So if you have your pancreas, you normally would have within your pancreas, in your islets of Langerhans, you have something called beta cells. And the beta cells within the islets of Langerhans produce insulin. So if, let's say that you wouldn't be able to see it right on here, it'd be very small. But if we zoomed in and we saw the beta cells and the islets of Langerhans, and we know that these are used to produce insulin. So we produce insulin, so let's say I for insulin, and insulin regulates blood glucose levels. So if your glucose levels rise in the blood, then the insulin lowers them by allowing the blood glucose to enter the cells. So the glucose in the blood will enter the cells to produce energy based on insulin coming and helping. So if you have your bloodstream here, so let's say you got your bloodstream, and let's say that you've got your glucose or your sugar that's in the blood, then when the insulin comes along and comes in, this acts as a key to open a door, and that door is a cell. So you've got your cells, cell, and now because the insulin came, now the glucose is able to enter the cells and be able to be used for energy, and this is how the process of the pancreas works to allow a person to get energy and use the glucose that's in the body. And then what happens if the insulin is not produced, or why would the insulin not be produced? So if there is any issue to these cells, these beta cells, and they are unable to produce insulin, then we have a problem, because then when we go back to our bloodstream here, then the blood sugar is just going to keep rising and rising and rising, and the insulin is not going to be there to allow the blood glucose to get into the cells. They won't have the energy because the cells can't use the glucose because it's just sitting in the bloodstream. And what are reasons this could happen? So in this example here, on the question, they're saying a congenital absence of the endocrine pancreas. So that would mean that the pancreas would be unable to produce the insulin because it's non-existent, because the endocrine pancreas is absent. There's no pancreas, so there's no pancreas, there's no insulin. And then now this question is asking, though, which of these diseases would be expected? So if you have this no pancreas, this would be very similar to if you had a pancreas that doesn't work properly. So in this example, absence of endocrine pancreas, there's no pancreas. So let's do similarly to if you had a pancreas but it didn't do its job, right? Because if you did have this pancreas but it's not doing what it should do, it's kind of the same thing as if you didn't have one at all. And what's a situation where you would have a pancreas but it's not doing its job correctly? It's not producing that insulin that the body needs. What if you had the cells, you're born with the cells, the beta cells, and now it's a Langerhans that can produce this insulin, but then they all get destroyed. And they get destroyed because of an autoimmune reason, meaning the body attacks itself. And do you remember what condition this is, where the body would attack itself, the cells can no longer produce this insulin, and then they have the same situation that we discussed earlier, where the blood sugar keeps rising, and they have no way to enter the cells. What condition would that be? That sounds a lot like type 1 diabetes, meaning that the body is totally dependent on insulin externally because the pancreas is not producing the insulin that it should be. And now looking at our choices, we see diabetes mellitus is an option here. So option C would be our answer, because in diabetes mellitus, it has a pancreas that does not function. Similar to in this example, there is no pancreas. So having no pancreas, or a pancreas that doesn't work, would lead to the same outcome, diabetes mellitus. And let's just review what these other syndromes and conditions are that are listed here. We've got giganticism, which just means it's a growth disorder where the person would grow to be very, very large. And that would not be the outcome of having no pancreas. So we can eliminate that. Turner syndrome, what Turner syndrome is, which is different than anything involving the pancreas. Normally, you would have, in a biological male, you would have an XY chromosome. That's like the sex assignment chromosomes. And then for a female, you would have XX. And that would give them all their feminine features, so female, and then the XY would be male. But what happens if one of these X's was not present and it's just a single X? They would have a lot of different issues with their body, right? Because they would have reproductive issues, other medical issues such as kidney issues, they might have learning disabilities, and that's what Turner syndrome is. So we can eliminate that because that's not the answer that we're looking for this question. And then option D, Addison's disease, that's a different endocrine problem involving issues with cortisol levels. So that's involving cortisol, not involving insulin in the pancreas. So we can eliminate option D here. And then that leaves us with option C, diabetes mellitus.